Morning everyone. Welcome to our next session where we'll be talking about continuing about our discussion of system of linear equation. So as you are already aware, we have covered a few topics on this point, which is introduction to system of linear equation. We also introduced row-echelon and reduced row-echelon form, and also we have gone through a basic system of solution of equation with the help of Gauss method. Today we will discuss our next point, which is Gauss-Jordan elimination, which is an advanced method of Gauss elimination. It is an algorithm or step-by-step process where we solve a system of linear equation. So if we have a system of equation that is a11x1, 12x2, up to a1 and xn is b1, 21x1, 22x2, 2 and xn is b2, which goes up to n1x1. As we are aware, this is how we write a system of equation. In the augmented form, the system will be returned as we keep the right hand side and we pick up the coefficient, which is a11, 12 goes up to 1n, 21, 22 goes up to 2n, and the last row is n1, n2, which goes up to nn. Our aim is to bring the reduced row-echelon form, that is a matrix which is only containing ones and zero by using row operation. So finally, we want to bring something which contains only 0 and 1. And from this, we can always infer that the first variable x1 is c1, the second variable x2 is c2, and the final variable xn will take a value of cn. Right. Let's understand the whole process with an example. So if we pick up an example, x minus 3y is negative 2 and 2x plus 3y is 40. Let's look at step-by-step method of how we will solve it. So first step is to, as we have seen in a Gauss elimination, first step is to write the equation in the row-echelon in the augmented form. So we pick up the coefficient, we have the right hand side, some author prefer to have a bar, some leave it as it is. So nothing is there, that means it's 1, negative 3 and negative 2, 2, 3 and 14. That's our first step. Moving on, what we will do is convert them into reduced row-echelon form, which looks like only 1 and 0. We should have a leading 1. So as you can see, the steps here on the screen as well. Yes, so that's our augmented form. What we need to do in step 2 is to bring a leading 1. Leading 1. So, the leading 1, we are lucky to have 1 here. If it was not, then we would either do some row operation, swapping it with some row, or applying row operation, so this becomes 1. The next step is to bring a 0 below this, right? So bring zeros, yeah, in first column. Okay, so in order to achieve that, what we will do, we'll take the first row, we will not alter it, right? Multiply row 1, you multiply it by 2, or call it minus 2. This will be your new row 2, and we'll add it into row 2. Again, we will not alter our first row. So as you can see here, I've written it here, bring 0 in the first column. So we will multiply the first row with minus 2 and add it into the second row. So it should look like, again, we are not disturbing the first row. So this is 2. I multiply this by minus 2 times 1. This is 3 minus 2 times negative 3, and this is 14 minus 2 times minus 2. This is our, which is equivalent to, again, no changes in the first row, 1, negative 3, negative 2. This has to be 0, that was the aim. This becomes our 9 and it is number 18. Step 4. Having reached this one, our first column looks exactly how we want it. 1s and 0, we will not disturb it again. Leading 1. Leading 1 in row 2. Leading 1 in row 2. How we do it? With some row operations. So here we will divide our row 2 will be original row 2 divided by 9. So it should take the form 1, negative 3, negative 2, 0, 1 and 2. This is our next step. If it was Gauss elimination, we would stop here, right, and use a back substitution to find the other variables. But this is Gauss-Jordan elimination, so we go a few steps more. As you can see, we got the leading one, but we need the 0 above it. So we proceed few more operations. Bring 0 in second column. How do we do that? Our new row 1 will be, this is 1, this is negative 3. It's very convenient if we multiply this by 3 and add it into the first one. So our new row 1 becomes row 1 plus 3 times row 2. So in this instance, our row 2 does not change. So 0, 1 and 2. This will be 0 thanks to, this will be 1 thanks to the 0. And negative 3 plus 3 times 1 and negative 2 plus 3 times 2, which finally will be simplified as 1 and 0, 1 and 0. You got a 2 here and we got a 4 here. Obviously, when we write them back into the system of equations, we can say that our variable x is 4 and y is 2, which is known as the solution of given system of equation, this. And we can always cross-check that. We can always cross-check that by back substitution. So when we have 4, 3, 2, that gives to negative 2, first equation verified, and you can always cross-check that. 2 times 4 plus 3 times 2 is 14, that's also verified. So this proves the use, what we have done is accurate. Thank you.